Okay, I would like to talk about simple harmonic motion and circular motion in this video. Okay, so what is simple harmonic motion? Simple harmonic motion is a motion under the influence of force described by the Hooke's law. And Hooke's law is F equals negative kx, where k is spring constant and x is the displacement. So let's look at simple harmonic motion's movement. So simple harmonic motion looks like this. As I mentioned, displacement is where the object is, and then amplitude is the maximum displacement, which means it's the distance between equilibrium and then the max distance. So displacement is maximum at the two ends. I'm pretty sure this is obvious. And the velocity, by the other hand, is maximum at the equilibrium at the middle, and then velocity is 0 at the two ends when the displacement is maximum. Now, acceleration is a maximum at the two ends. Acceleration is 0 at the equilibrium, so it's the other way from the velocity. It's the same as displacement. So let's look at the graphs. So as you can see, displacement, it starts at the maximum displacement. So it's starting at positive amplitude. The simple harmonic motion is starting at positive amplitude. As you can see, velocity is 0 when the displacement is maximum, and then acceleration is negative maximum when the displacement is positive maximum. And when displacement is 0, it's at the equilibrium, velocity is negative maximum, and then acceleration is 0. So velocity is maximum and acceleration is 0. So as you can see, when the displacement is maximum, acceleration is also maximum, but velocity is 0. And then it goes the other way for equilibrium. So the equations for displacement, velocity, and acceleration graphs are shown. Displacement is a sine omega t. Velocity equals a omega cosine omega t. And acceleration is negative a omega squared sine omega t. And the omega is 2 pi over t. It's the angular frequency. It's the frequency in like angular motion. Okay, so let's talk about period and frequency now. So a period is the time to finish one complete cycle, and then frequency is the number of complete cycles per second. So the reciprocals, like period is equal to 1 over frequency, and frequency is equal to 1 over period. Okay, so in period in spring mass system is period equals 2 pi root m over k. So spring mass system looks like this. So when the mass of the object increase, the period increases, so it takes more time to complete one cycle. And then when the spring constant, so the stiffness of the spring, when that increases, the period decreases, so it takes less time to complete one cycle, so it becomes faster. And then frequency is 1 over t, so it's the other way. Okay, and then in pendulum system, pendulum looks like this. So period is equal to 2 pi root L over G, where L is the length of the rope. And then so when the length of the rope increases, it takes more time. So the period increases. It takes more time to finish one complete cycle. And then so gravity and Earth, it won't change anything. But for example, if you do the experiment, or if you have the pendulum and moon, since gravity is less than Earth's gravity, it will increase the time and will increase the period. So it will increase the time to finish one complete cycle. So by changing for a spring mass system, you change the mass or spring constant to change the period in frequency. And pendulum, you change the length of the rope, and if possible, change gravity to change the period or frequency. Okay, so let's look at this. So this is a normal simple harmonic motion. And let's look at the circular motion. You might not see the coloration right here, but let's look at this video first. So it might be hard to see, but if you look at this, it's pretty obvious how the object is speeding up at the middle, and then it's decreasing at two ends. So it's following the simple harmonic motion rules, or a simple harmonic motion the movements. But as you can see, we're just moving the chair in circular motion, and so the object is just moving in circular motion, but from the vertical, you can see how it's moving in a simple harmonic motion. So let's break this down. Let's break this video down. Okay, so now we plot this video. We plot the points for each movement, and then as you can see, there's a lot of dots at the two ends, and there's less dots in the middle. That shows how velocity at the middle is really faster compared to velocity at the two ends. The velocity at the two ends are 0, therefore there's a lot of points. Okay, so let's look at the graphs now. Okay, so as you can see, that was a circular motion, looking from the horizontal direction, but as you can see, it's negative sign graph in this case, so it's following the graph for displacement graph for those graphs that we went over for simple harmonic motion. Okay, so the circular motion and simple harmonic motion are really similar. So if the object is moving in a circle in a vertical, if you look from the side, it's just going to move in circle. But if you look at it from the top, it's just moving this way. But it follows a simple harmonic motion moving in this way. So simple harmonic motion is only one-dimensional. Like as you can see, there's one-dimensional, but circular motion is two-dimensional. It's vertical and horizontal direction. So that's the difference. And then they follow. They have a lot of common things between them, and then they have a lot of coloration between them. Thank you.